carry on from the previous lesson. Now, for those who are new, in the first two lessons, we spoke about using laws of exponents, and we got more comfortable with that. And then we worked on simplifying expressions. So simplifying expressions using the laws of exponents. And so we're going to start with this question today. But before we start, I would love somebody who has been here previously to just share their thinking about how they might approach this question. So based on what we did last week, if someone could come online and just give us their basic thinking about how they would approach this question. Yeah, Fila, let's go to you. Hi, Fila.
Hello. So I would start by, what do you call this? Getting a prime number of 6, because it's not a, what is it? It's not a perfect square.
You're right. Yeah.
So I would simplify that, and I'm thinking I'm going to get like 2 times 3 and then put it in brackets.
Perfect.
And then with 4.
Yeah, go with the 4. Yeah.
With 4, I'm going to change it into an exponent, and I'll put it in an exponential form, which is going to be 2 to the power of 2, and then I put it in brackets. And I'll just leave it like that because I think 3, the denominator is already simplified.
Yes, that's perfect. So you have given us a lot. So I just want to pause for a second. So thank you, Fila. What Fila said is exactly the first step. So you need to break this into, the bases need to be written as prime numbers. So I want to give you a chance to work with that. What Fila said is that basically you can't use the exponent laws unless the bases are basically broken into their prime factors. And so I'm going to give you a chance to start with that and see if you can simplify this expression. So over to you guys, give it a go, and then I'll give you feedback in a moment. Thank you for that, Fila, and thank you for everyone else who put their hands up. I will definitely be coming to you soon. Yeah, and Paul, what's your question or comment?
Hi, sir. I don't have a question. I just want to answer how I've been attempting this question, basically. So what Fila said is pretty much right. The numbers as a factor of their prime bases, basically. So that's what I did. And then I got 2 to the power of 2m times 3 to the power of 2m multiplied by 2 to the power of negative 2m. All of that over 3 to the power of 2m. I'm just checking it. Yeah. Okay.
You're looking good. So what you were doing is you were basically doing the second step where you apply, in fact, I'm not going to write it as 2, I'm going to write it as 2 squared. Yes. And so from what I've heard, you basically did 2 to the 2m, 3 to the 2m, and then 2 to the minus 2m over 3 to the 2m.
Yes, yeah.
And I completely agree. Yeah, that's exactly right. So let's give a little bit more time and then pop the answers in the chat, but I completely agree with you. So what is our final answer going to be? So lots of people's answers are coming through. Keep them coming, guys and girls. So there's 2 options you could use. You could either bring the 3 to the 2m to the top, and it becomes 3 to the minus 2m, or you can recognize that 3 to the 2m on the top and 3 to the 2m on the bottom cancels out as 1. And then all you do is you get that, which is 2 to the 0, and 2 to the 0 is just 1. Yeah, so the answer is 1.
Well done, everyone.
So the steps there are, basically prime bases. But let's actually have a look here. There's a little cheat sheet here that I've got. Well, not cheat sheet, but you know what I mean. So rewrite all composite numbers as products of their prime factors. Use exponential laws to raise all powers appropriately. And then use the rule for division to move all bases into the numerator. So basically, that's just moving things from below above. However, in this scenario, we could cancel out because there was the same on the top and the bottom. And then final one is simplify. So for this type of question where you just have multiplication and division, this is the process we're always going to follow. Right. So you did quite nicely there. So I think we're going to do another one just to confirm. And then if you get that, if that goes well, then we will probably move on. So I want you to simplify the following expression over there. And then if you have any questions, oh yeah, Kanya, put your hand up and we can answer your question. Weren't we supposed to sync the 2 with the negative m? Okay, so I'll go to that now. Kanya, let's chat while we, yeah.
Hello.
Hey.
So while I was working this out, I did all of that, and then I got to the step where I had to cancel 3 to the power 2m and 3 to the power 2m, and then I got 2 to the power 2m times 2 to the power negative 2m.
Did you move your 3 to the 2m to the top, which is, it's fine to do that. Is that what you did?
Yeah.
Okay, so how would that method work? The way it would work is you would say, look, you've got your 2 to the 2m, right? And you've got your 3 to the 2m that is there, and you've got your 2 to the minus 2m. The only thing that needs to happen is when you bring the 3 to the top, it becomes 3 to the minus 2m.
I did not bring it to the top.
Oh, okay. You didn't?
No, I canceled out.
Okay, but then canceling out is fine because that would cancel out these 2 over here.
Yes. And
so
then
now,
I was left.
Yeah.
I did cancel 3 to the power 2m. And then
Yes.
I was left with 2 to the power 2m times 2 to the negative 2 times 2 to the power negative 2m.
Do you understand how I got from that? I got to 2 to the power of 0.
No.
Can you see? Okay, so here's what we need to do. If you have 2 bases and you're multiplying and the base are the same, you just add the powers. And so what is 2m plus minus 2m? It's just going to be 0. And that's why I get 2 to the 0.
Oh, okay. Thank you. I got it.
Yeah. Pleasure, pleasure, pleasure. That's what I'm here for. Okay. Thank you for the question. Yeah, Letabo, let's go to you. What can we unmute Letabo? What's your question?
Hi, sir.
Hey.
I wanted to ask for the 27 to the power of 2 minus x minus 2. Do you have to simplify the 27?
You do, because the 27 is not a prime number. And so what we're going to do is, and the same with 9, we have to basically break it down. Let me use my highlighter here. So the 3 is fine because it's a prime number, but 27 can be rewritten as 3 cubed. And the 9 can be rewritten as 3 squared. Okay, does that make sense?
Yes, sir, it does. Thank you.
Okay, so then you must carry on the journey from that point.
Okay.
Cool. See a few answers coming through. Let's keep swimming here. So what is a little bit sneaky is this bit. So what I've done is I've done my various stages, and I actually kind of put these two together. So the bases are the same, so I just added the powers. So that part is fine. And then on the bottom, I've got this. Now, I think at this stage, the easiest way to deal with this is just to bring the 4 to the x to the minus 8 to the top. And what we get then is just 3 minus 4x plus 8. And I want to really focus on how this is plus and minus, and then it becomes minus plus. So it changes its sign. But the nice thing now is it's just a multiplication. And so if we do that, we should then get 4x minus 4x minus 5 plus 8, which is just going to be 3 to the 3, which is 27. This isn't the only way to do it, but I think that it's, probably one of the easier ways to do it. Are there any questions or comments? Because I suspect there might be. And I'd love to interact around that. So just look, you might have got most of it right and then just had a little problem with one of the things. Okay, then what I'm going to ask you to do is take a screenshot if you need to, if you want to spend some more time on this, and I'm going to move on to the next one. Yeah, 2 participants. Okay, what is the questions there? Let's have some questions.
So I wanted to ask, with the 3 to the power 3 and bracket x minus 2, how do you go from that to 3 to the power 2x minus 6?
Okay, so the one on the bottom, if I multiply these two together, do you agree I get the 4?
Yes.
And then if I go across to the next step, can you see if I multiply this, I get this one over here?
Yes.
Okay. And then, so you find on the bottom there, and then on the top, can you see how I get 3x minus 6 by just going 3 times x and 3 times minus 2? So I just get that.
Oh, okay.
That's how I did it, yeah. And then I had to put these two together. So I got x plus 3x is 4x. 1 minus 6 is minus 5.
Okay, thank you.
Cool. Let's do one more like this because I can see we're not quite there yet. So let me just grab another question that we haven't done before. Let's just do this one and then we'll move on to a different type of question. Did I get the right? Let's grab another one quickly. Oh, there's actually one hiding down here. Let's do this one then. I want everyone to try and simplify this question for me. Okay, and then while we're working on that, for those students who feel like they have questions, you can ask your questions while other students are working on that question. Yeah. Kanya, let's unmute you.
Hi, sir. I want to ask, how did you get 3 to the power 4x minus 5?
3 to the power of 4x minus 5. So is it this part over here that's causing confusion, that one?
Yes, sir.
Okay, focus on the yellow bits. Can you see that the bases are the same here?
Yes.
Now, if the bases are the same, I simply write down 3. Okay, so I write down 3, which I've done here, and I add the powers. And if I add the powers here, I get x plus 1 plus 3x minus 6. And so can you see what is x plus 3x? It's going to be 4x, isn't it?
Oh, okay. Yes.
And 1 minus 6 is minus 5. So that's how we got it.
Oh, I did a mistake. Thank you.
No problem. It's easy for silly mistakes to creep in this topic. I know myself. So you have to almost double check just to, yeah.
Mr. S, can you take another question?
Yeah, I can. Absolutely. What's the next question?
Hello, sir. Can I please ask, there at the end of the question, there is 3 to the power of 3. And then why did you say equals 2? And then in the block, you put 2.
Oh, sorry, I put 27. It's 27.
Oh, okay.
Yeah.
Thank you, sir.
Cool. So once you've, my first step in the next question was this. Basically, I broke that one down. I also broke this one down. So Kamogelo, I like where you're going. We like to leave our answers with positive exponents if possible. So see if you can write your answer with positive exponents, but I like what I'm seeing on the whole. Oh, not minus 3. I'll tell lies. 4n minus 6. Don't worry, Vuchilo. The good news is the whole lesson is recorded, and so you can have a look at the first part of the lesson later, so you can catch up. So, but I appreciate your apology. Okay, so I want to see, has anybody else got some answers coming in? Ntokozo, let's go to you. What is your question? Could we unmute Ntokozo?
Yes, I'm kind of confused with the answer I got.
Okay. Are you with me so far in the steps that we've done?
Yes, I am.
Okay. Now, my next step would be to say, well, can you see the 5 to the 2n on the top and the 5 to the 2n on the bottom? Did you spot that?
Yes,
So that's
one.
Okay. So now what I'm going to do is, have I left, just make sure I haven't made a silly mistake, because I'm having a moment where I'm like, just want to check myself. Okay. I think I'm going to move the stuff on the bottom to the top.
Yes.
So at the moment I have 4n minus 6. Then I get 3 to the minus 2n. And then I get 3, so minus 4n plus 1. So would you agree with me on that step?
Can you please repeat?
I can. So the 2n over here was below the line. It became minus 2n when it appeared above.
Yes.
And then the 4n minus 1, when it's below the line, when it goes above, it becomes minus 4n plus 1.
Yes.
Okay, so now all the bases are the same. So I think I can just go 4n minus 2n minus 4n, and then minus 6 plus 1. I just put the n's together first. So that gets rid of that. So I should get 3 to the minus 2n minus 5.
Oh, I got it right. Thank you.
Okay, no, but now there's one more step. So the one more step is to make these exponents positive. I bring them below the line and I get like that. Does that make sense? How and you don't absolutely have to, but normally the questions say, leave your expression with a positive exponent. And that's the way I'd change it from negative to positive.
Okay. Yes, I do understand.
Perfect.
Thank
All right.
you.
So what I'm going to suggest, for those of you, if it's your first lesson today, you might find we're going a little bit fast because we started this question in the last lesson. On the whole, I know our understanding isn't perfect, but I'm pretty happy with what I've seen so far. And so what I'm going to suggest is we take our break a bit earlier tonight so that we have a second half of the lesson dealing with a different type of question. And for those who are still feeling a bit unsure, just have a look at the previous video recording as well. You'll see that we start this process in the previous lesson. Okay, but what I want to see is I want everybody to turn on their cameras, and I want you to join me in having a little break. So turn on those cameras and stand up and let us give our bodies a break, because when you're using your brain intensely, it kind of has a peak period and then it hits that. And then after that, your attention just goes down. Okay. So what are we going to start with? We are going to start with, oh yeah, pat yourself on the back for doing such a good job. There we go. We'll start with that. Well done.
Please join us, guys. Put on your cameras.
Turn on your cameras, and then let's do a tricep stretch. So let's start with that. Tricep stretch. Feel your shoulders that have been leaning, hunching forward. Feel them unwinding. Oh, there we go. And then switch over. Oh, doesn't that feel good? I feel alive.
Oh, yes.
And then, oh yeah, let's loosen the shoulders a little bit, because our shoulders get very tight when we hunch forward and looking at the screen. So let's roll those shoulders a little bit.
Your body will thank you, guys.
And then do a bit of a neck stretch there. Stretch it out there. See that range of motion is.
Oh, getting some clicks there.
Yeah. Okay. And then, yeah, just do one more shake. And what else should we do? Level, what do you think would benefit the students? Any ideas, or anybody got a favorite stretch they want to show us?
Ooh, putting me on the spot there, Mr.
Oh, sorry. I quite like, okay, maybe, what about this one? Have we done this one yet? I don't think we have.
No, yes, we haven't.
It's another good shoulder stretch. There we go. And switch to the other shoulder.
Maybe let's see if they can use this arm to touch the fingers on the other arm.
Oh, yes. Okay, should we try and do that? Oh my gosh, this is going to be awkward. I can't. Let's try this side. I can on this side. On the one side I can, on the other side I can't.
Yeah, sometimes the one arm is more flexible than the other one.
Yeah, no, it is. It's actually that's an interesting one. Thanks for that.
Shout out to all of you guys.
Well done for participating, everyone. And we don't just do this to be silly. I mean, partially we do, but it's also, there really is benefits to doing this, because your brain can unwind and it kind of resets your concentration. So let's do a little brain break puzzle. I want to know, what the last line is equal to based on this little puzzle that I've thrown into the screen here. What do you think the answer is to this? Let's have a look. I'm pretty sure this has to be 10. But now, these tricky bananas, you need to be careful. 4 bananas plus 1 cookie is 14. How much is 1 banana worth? So 1 banana, I think, has to be 1. Well, yeah. Because there's 4 bananas plus a cookie is 14. So each banana must be worth 1. Now, what are these fancy biscuits going to be worth? Well, there's 2 already, and it's 8. So they must be 6 together. And if there's 6 together, they must each be 3. So now the question is, what is the final answer going to be? Now, the problem is there's a thing called BODMAS or PEMDAS that tells us what you need to do first. And according to BODMAS, you need to do multiplication before you do addition. So the way this number expression would read, it would be 3 plus 1 plus 10. And so the answer will be 14. Okay, so what normally catches people here is the 2 bananas to the 1 banana thing. So each banana is only worth 1. Okay, don't worry,
Tenderness is crying.
It happens. So each time we do this, you'll notice that you get used to it. This is called a simultaneous equation in mathematics, but it's always kind of underneath these funny questions you see on the internet. But well done, Ntokozo. Okay.
Good job, guys.
Fila, yep, BODMAS is real, hey? It's not going anywhere, right till the trick. In fact, even in the real world, BODMAS will find you. So watch out. Going back to those good old grade 8 days. Okay, so the good news is you'll get another chance to do one of these puzzles on Wednesday. So even if you did get caught out now, you have a chance to have a go again on Wednesday. But let's get back to what we were doing. So give me a thumbs up if you are ready for the second part of the lesson. And give me a thumbs down if you're like, oh my gosh, my brain is dead.
The people are asking for more.
And more, okay. So no dead brains yet, no zombies. I should have like a zombie thing here. The idea behind the stretching is that it kind of gives your brain a bit of a lift. Okay, so in this section of exponents and surds, when we ask you to simplify an expression, they don't always involve just multiplication and division. Sometimes they look a bit different. And I want to ask for some thinking, if you could share your thinking, what makes this question different to the ones we've done already? I'd like to know if someone could raise their hand or share their thinking about what makes this different to the previous one. So yeah, let's ask Yenzi, or yeah, Yenzi, let's unmute Yen or Tebogo otherwise. Hi Tebogo, what's different about this?
Hello.
Hey.
I think what's different from the ones that we've done before is because this one has a negative sign.
Yeah.
And the ones before had multiplication.
Yeah, it's exactly that, eh? So this negative sign makes life difficult because we can't apply, like the laws are defined for multiplication. And so the situation like this, when it's not being multiplied, when it's being subtracted, we need a different tool from the mathematical toolkit. And I'm not sure if I'm pronouncing this right, but MOMF is suggesting factorization could be involved. And I agree with you. And so the way we handle this type of question is we actually look at the line that has multiple terms, and we break up the term that has basically to show us a common factor. And so what I would do is I would rewrite this top line like this. And what I then see is that there is a common factor between the terms of 2x, or 2 to the power of x. Just give me a thumbs up if you see that that common factor is hiding in those two terms. Just want to see if you guys get you, because the main thing initially is to go, well, we can't use the laws. We have to use a new technique. What, how do we use this technique? Okay, so we're happy to see the common factor. Now, the problem is we're not done. When you factorize something, you take out the highest common factor, and then you write what is basically what you need to, is that if you had to multiply it out, you get back to what you started with. So what is left behind when you took out the 2 to the x? What's left behind is the 2 to the 3. And what is left behind when you take out the 2 to the x over here? It's just the minus 2. So what I write is I write 2 to the 3 minus 2. So notice how if I multiplied this out again, if I multiplied this out, I'd get exactly back to what I started with. I'd get 2 to the x plus 3. And if I multiplied this out, I would get back to what I started with. And that's the point. It's reversible. Now, on the bottom, we haven't done anything. Now, what do you think we're going to do? What we've done is we've transformed the top line to be a multiplication. It's now 2 to the x times these other things. So what do you think I'm going to do now? You can put it in the chat. Yes, so now that it's multiplication, we are going to cancel out the 2 to the x and the 2 to the x. Because now we're allowed to cancel because it's been factorized, or it's multiplying on top and dividing on the bottom. So what do you think my final answer is for this question? Pop it in the chat there. Okay, so the final answer would just be 2 cubed, which is 8, minus 2, which is 6. Okay, perfect. So what did we do to solve this question? The first thing is we recognized it was different, that it was no longer a multiplication, but a subtraction. We then had to split the term, and then we took out a highest common factor, and then we simplified after that. I'll show you the little note in a moment, but it's not too bad. But the main step that students forget is in an exam or a test, they'll go, oh, I can cancel this with this. Or they'll say, I can cancel this and this, and then you can't. You have to factorize that first step to get going. So what I'm going to do is I can see there's some questions, and I'm going to set another question like this. And while you get busy with that, I'm going to answer any questions there are on this one. So let me bring out my worked example. So here is my worked example. I want you to try and simplify 3 to the x plus 1 plus 3 to the x. Notice how this is an addition with two terms, if there's no multiplication. See if you can use whatever techniques you observed in the example above to help you. And then if anybody has a question, I see a hand is up from Kanya. So let's go to Kanya.
Can you please explain the first one? Because my phone just went off and I couldn't even hear a thing.
Okay. So in the first one, I first recognize that this looks different. And on the top, there's a subtraction going on. So this subtraction means that I can't do the normal method. And the technique we're going to use is factorization. And in order to use factorization, the first way to factorize is the highest common factor. And so I take this term over here, 2x plus 3, and I write it in a split form where I write it 2 to the power of x times 2 to the power of 3. And when I write it like that, I notice that the 2 to the x is common to both terms. That's the one in yellow. So I take out the one in yellow and I ask myself, what do I write in the rest of the bracket that it is factorized? And what's left behind is the 2 to the 3 here. And over here is the minus 2. And once I've written it in factorized form, I can now cancel out the 2 to the x's. I'm allowed to because it's a multiplication on top. And then all I'm left with is 2 to the 3 minus 2, which is then 8 minus 2. And then I get 6. So even if you have to look at that again, or the recording to have a look at how I did it the first time, I hope that gives you a little bit of help. Now, in the second question, the same thinking is going to apply. I look at this and I think, oh, it looks like there's a common factor, but I can't see it yet. So I'm going to write this as 3 to the x times 3 to the 1 plus 3 to the x. So now I look at this and I go, what's the common factor to both terms? It's going to be 3 to the x. Okay, that's great, but I still need to factorize this now. So what is my highest common factor? It's 3 to the x, and I need to write something inside that. What is going to go inside that bracket? I want you guys to tell me in the chat or to raise your hand and tell me how you got what goes inside that bracket. Okay, let's go to Pumonte. Is it Pumonte? What do you think goes inside the bracket? Can you hear me, Pumonte? I'm asking you to unmute if you can. Otherwise, I'm going to go to the next slide.
Hi, sir. I wanted to ask a question about the previous one, but you answered it when you're explaining it to the other lane.
Okay, no problem. Would you agree with me that it's going to be a 3 inside the bracket because there's a 3 left here? Okay, cool. So then there'd be a 3. Now, what's a little bit sneaky is there's actually a phantom 1 in front here. And so we need to put a plus 1 over here in order for it to work. And then we'll see that we get 3 to the x times 4, or normally we'd write it as 4 times 3 to the x. So that is showing you again how you can use the technique of factorizing. The thing that I think would catch out a lot of people is this 1 in front. But remember, if you're multiplying out to get back to what you started with, you need something to take its place, but not change the value. And so that's what the 1 is doing. Can you give me a thumbs up in the chat if you understand how I got the 1? Give me a thumbs down if you don't understand, because I think that is a bit tricky. Okay, so it's almost like whenever there's nothing in front and you need something to fill in its place, you can just put a 1 there. So you'll see this come up again, but I just want you, I call this the phantom 1. There's always a 1 in front of something if you want it to be there. So I noticed in the chat, it's a bit of a mixed reaction. So I will try and find another example where I point out the phantom 1. Okay, I can see that there's a bit of mixed, not everyone. Okay, let me think about it this way. Everyone can see the 3 to the x. There's no problem there. Fine. Now, what's next to the 3 to the x? There's a 3. So that's why I write this 3 here. Because 3 to the x times 3 gives me this first part here. But now I've got a problem for the second one. If I've got 3x outside and I want to multiply by something, how do I get back to 3x? What's the only number that I multiply 3x by to get 3x? The only number that you multiply 3x to get 3x is 1. And the way of seeing that the 1 is there is 1 times anything doesn't change the value. That's why I call it a phantom 1. It's always there if you want it to be. But I'll explain it again a little bit later in the lesson. But I hope for now that kind of gets you on the right track. Okay, let us do another question. Now, getting a little bit trickier, but not too bad. We're going to do this together. So, if we look at this question to start with, the top line is an addition, the bottom line is subtraction, and if we need the question, the key word is to simplify this expression. So let me make sure that that is clear. You need to simplify. Now, you cannot use the techniques of the laws here because it's addition and subtraction. So what technique am I going to use when I do the top line? Tell me in the chat, what technique am I going to use? Let me know in the chat.
Any ideas, guys?
Okay, common factor, factorizing. Kat, you are on the money there. Yenzi, winning at life. Pomunte, just too good. So now the next question. What is that common factor going to be? What is that common factor going to be? I'll give you a little bit of help by rewriting it, by splitting out this term. So what is the common factor going to be on the top line? I think the common factor on the top line is going to be 5 to the x. And I'm going to leave the second part blank for now. Okay, so I'm going to leave the second part blank for now. We'll come back to that in a second. Now I want you to look at the bottom line. And I want you to tell me what is the common factor for the bottom line. So everyone, I can see in the chat that you are telling me it's exactly the same, and you are completely correct. Now, I just want to point out, in order to see it, look at how I split. I took this and I split it up into pieces in order that my common factor was easy to see. And I did the same thing here. Notice how I split it. If you split it, it's easier to see that the common factor is the same thing. So you're right. The common factor is 5 to the x. Now, we're not done. Let's go back to the top. What do you think is going to go inside the top, the numerator's bracket? I want to know where this blue thing is. What do you think is going to go in there? Maybe somebody can even come online. I can hear your voice. That would be awesome. Or you could put it in the chat, whatever works for you. But
We love to hear your voices, guys.
Tando, where to? It's going to be a 2 to start with. You're absolutely correct. So there's the 2 for the first bit. What do you think is going to be in the next bit? Plus 5 to the minus 2, which is this bit over here. So notice how it's almost like I'm just grabbing the pieces that are left behind. Okay. What about the bottom? I want to know what is going to be in the bottom.
Mr. Ace, we have a hand from Monica.
Yeah, let's go to you, Monica.
Okay, so for the bracket, it's going to be 3 multiplied by 5 to the power of 1.
Perfect. So what I'm going to even do is I'm just going to write it as 15, because that makes sense there. There's 3 times 5 that's left. Would you agree?
Yes, sir.
What do you think the next bit is?
It's going to be -10 to the power of -1.
Okay, so what was left behind? There was -7 times
Oh,
5
no,
to
yes.
the power of -1. Hey?
1.
Yeah,
Yes.
perfect. Okay. So, guys and girls, are we all okay with it up to that stage? I know this is a new question, but are you with me so far? Yes, absolutely. Not really. Okay, so we're going to carry on with this type of question, but the first step is really noticing that you can't use the normal process, and so you need to instead use factorizing. And then when you realize that it seems like whenever we factorize, we need to take out a common factor. What I'm noticing is that the bit that you're struggling with is how to fill out these 2 brackets over here. That's what I'm noticing. So we're going to practice that. But I just want to, so I'm going to practice that again with you before this lesson ends today. But let's just see how this question would finish, because I've got the answers here that I want to show you, right? So let's see if I can. Okay, so bring up the answers here. So this is the long-winded type of thing. I wonder if this is that helpful. Okay, you know what? In the next lesson, I will come back to this question and I will continue with it. I just want to, I think doing the second, okay, let me, yeah, let's practice this first bit again. And then in the next lesson, I will finish off this question and show you how to go. But basically the first step here, the next step was going to be to cancel the 5 to the x's. So does everybody understand how I would cancel the 5 to the x's? Give me a thumbs up if you get that. Give me a thumbs down if you understand, if you don't understand why I would cancel the 5 to the x's. Okay, so everyone's got that. So we'll come back to this question the next lesson, but let's just practice the skill that we're learning, which is this first part. So let's try out our thinking on this next question. If I said to you, simplify this exponential expression, I want you to try and do the first step by yourself. So try and do the first step by yourself, and then let's see how it goes. I'm going to give you 2 minutes to do that. And the goal is to simplify this expression. Capano, I'll have a look here now, in case I've made a silly mistake here. 2 plus 5 minus 2. 3 times 5 is 15. Minus 7. No. So we only use the 1, Capano, when there's nothing there. So in this question, there were numbers that were already there. And so we didn't need to think about the 1 because we already had something next to the 5 to the x. Does that answer your question? So we only use the 1 when there's nothing else there. But in the case where there is something next to it already, it's fine. Yeah. Okay, pleasure, Capano. So what do we think our first step is? I think it's to spot that the top line is, we can't use the normal thing about breaking down into prime bases. And the other thing is the bases are all the same, but they're being subtracted. So what I'm going to do is I'm going to write this as this. Now, if I do that, and maybe I should even, I'm a bit zoomed bit zoomed out and my things aren't quite thick enough here. So let's make this a bit clearer. So try and see if you can get to the final answer, but you get 2 to the a times 2 to the 1. And here we get 2 to the a times 2 to the minus 1. The next step is to realize that the top has a common factor, which is 2 to the a. And so if I wrote that 2 to the a, I would get this. And the bottom, the good news is I already have 2 to the a. So now we ask ourselves, what goes inside the bracket? Well, what's left behind here? We have 2 to the 1. So that's 2 to the 1. And then over here, we have minus 2 to the minus 1. Now, why do I get that? Well, I get that because there's the 2 to the minus 1 here and the minus there. Okay, you can't really, oh, sorry. Let's bring that back. So you can see that this bit over here is what I take out. Okay, what do you think the final answer is? Put it in the chat if you think you know what the final answer is. Okay, we're getting close. So I know that the 2a over 2a can cancel out. So I'm just left with 2 to the 1 minus that. And it turns out that because I know my laws of exponents, I can rewrite this as 1 over 2, so 2 minus a half, because I'm just taking it below the line. So what is 2 minus a half? It's just going to be 3 over 2 or 1.5. That would also be correct. Now, this is a harder type of question. And the reason I've covered it is that, yeah, it does come up in tests. And if you're getting sort of above 50%, this type of question is the one that's going to get you even higher, above 50% to 60 or maybe a 70%. So the question about the phantom 1 in this scenario, there is no phantom 1 because we already have something that is taking up the space. So can you see that the 2 to the minus 1 is the bit that is next to the 2 to the a here? And over here, the 2 to the 1 is next to the 2 to the a. So the phantom isn't necessary. You could write a 1 in front and it wouldn't change anything, but it doesn't have any meaning in the same way as it did earlier. Like if we go back to that earlier question, let's just do that. Notice how the 3 to the x has nothing in front of it, or no, it has no partner to almost go with it. That's why the 1 was so useful. Okay. Homonte, that is fantastic. So that will come up again. But yeah, so I think we're going to start to finish off for today. So I want to outline what are the 2 main things we've done today. The first type of question, we worked with prime bases and using the laws of exponents to simplify. The second part of the lesson, we looked at a new type of question where the exponential expression basically was written with separate terms and it was pluses and minuses. And we used the technique of factorization, well, splitting and using factorization. And then once we knew how to do that, it turns out we can still simplify more complicated looking exponential expressions. Okay. I'm going to leave it there for today because I feel if I push too much more, this needs time to settle in your brain. And then on Wednesday, we will continue with this type of question. Okay. But I'm just going to say, unless there are any final questions, if anybody wants to ask any more questions, now is a good time. Otherwise, you are dismissed for the lesson. And if we could just fill in the poll, I'm going to launch a poll. And if you could just help us by filling in the poll so we know roughly how you're experiencing the lesson, that helps us plan in future. Okay.
We really appreciate your feedback, guys. Please fill it in before you go.
Yeah, no, we really do. It helps us. So Tato, it's a 1-hour class. We do what's called a foundation class from 5 till 6, which goes a bit slower than this class. And then the next class is from 6 till 7, which is your class. So we do 2 hours, but we do the same content, but at 2 different levels. So surd equations is lesson 5 in Paul, according to my planning. You'll notice that my planning has simplified, sorry, lesson 6. So 5 is simplifying surds, 6 is solving surd equations. Yeah. All right. Thank you, everyone.